I heard about is that quantum computer is about 150 million times faster than the supercomputer, the fastest supercomputer right now. Is that true? I- Is it that
Y-
fast?
yes, and it gets faster the more qubits, or and qubits could essentially replace the bits in a classical computer. But the qubits serve as that
What's a
circle,
qubit?
right?
What's
A,
qubit actually?
so a qubit is it simulates an atom. So when you're using a quantum computing, basically you're computing and simulating the natural dynamics of the universe, right?
Hmm.
And
Hmm.
so instead of computing in a analog way, right, where you're using the zeros and the ones, you're going beyond digital, and you're essentially mimicking the optimizations in the universe, right? Because the universe is already optimized. So think about it. With an atom, you can build anything with an atom, right? You can build anything with an atom.
It's a
So,
building block. It's a building
yep,
block, so we can do.
it's a, yep. But with a bit, you can't build anything with the bit, right? It's limited, and so it forces us as developers and programmers and creators to completely break how we think about computing and what the possibilities are, different programs or applications that we can create. There's different ways that we can show and simulate and express the technology that goes into our applications, for example. So you may simulate a process that or an algorithm, right? But normally when you create an application, your customer doesn't get to peek behind and see that algorithm, right? So that's actually perfect for artificial intelligence, where there's a huge issue with the lack of transparency with AI models and algorithms. But with a quantum application, that a hybrid, for example, that you simulate on a device, you can actually show the user the processes that take place and simulate those processes, so that the user gains more insight into the inner workings of that artificial intelligence model and how it comes to its conclusions and its results.